Good evening. Welcome to the sixth session of Fundamentals of Additive Manufacturing Technology. So, is it audible? The voice is clear, right?
Yes,
Yeah. So today we will discuss concepts related to the cubic technology, how the processes work, what are the different parameters, like what type of material we use, what type of approach, cutting method, bonding method. Uh, so we will discuss for all the different technology methods, cubic technology, Kira's paper lamination technology, and solid dimensions plastic sheet lamination, um, CAM, LEMCL, which we'll discuss ceramic related, and ultrasonic consolidation, and finally, then we'll also solve some questions related to them. So we'll start with the first discussion. Okay. So this is the cubic technology LOM. So okay. So this process was developed by Hensis. So, for this technology, they had also applied for a patent in 1996, but which is over already in 2016. Now, um, so this technology can be used now without giving any credit to them. Okay. So the material we use in this process is a paper sheet. Okay. So the thickness of paper sheet, this is between 50 to uh, approximately 100 micrometers. Okay. So generally we don't use paper like this, like not the white papers which we use. They're the those we don't use wire paper like this, not like the white papers. Okay, so the papers are made from the trees. We cut the to take the pulp and then we leach it so that we remove the brown color of the wood. But in this process, that is whatever I am talking about. Uh, it is like about the paper which we use generally. We take it from the pulp, we leach it, we remove the brown color of the wood, and then we use. But the paper which we used here is not bleached. It is actually same as the same of color as of wood. We don't use bleaching, so so in this paper are coated with adhesive. So you can see like the new layer which is formed here. We are making in laboratory only one sheet of paper, and that will apply that on top of it another sheet will be applied, and on all these previously deposited layers finally we will apply a roller. Only one single roller is there, and this roller will move from left to right side, and it will apply a load. And because of that, two adjacent sheets, these adjacent sheets will be joined. So in this approach, we are using the technology that is bond then form. So we are making a bond adhesive, and then we will cut the remaining portion, that is the supports the extra portion we'll cut first, and then again uh, then there is forming, and to remove the extra portion we use laser. This laser is used. This is the CO2 laser we use here, and but this laser is not like the laser which we use in selective laser melting process. We use laser where we use like in the range of 200 to 250 watt. Even sometimes 1000 kilowatt laser is also used, but in this we don't need SLM process. We use selective laser melting. The laser which we use is in the range of 200 to 250 watt. Also, some cases we use 1000 watt, but here we use a power of less than 10 volts. But here in this method, we use a power of less than 10 volt. This will work fine. As for bonding, why so much less power work can be done? Because for bonding we use an adhesive. For bonding we use an adhesive, uh, and joining. So what portion of area that will be joined? Like if one, this is one sheet we have, and I have to apply a glue on whole area, and the whole sheet will be joined to the adjacent sheet. So the entire region will be joining. But in other processes, in some processes we not require that the entire region is joining. So a selective portion is required. So in that case, our process will be selective deposition lamination. Okay, some processes selective deposition lamination. Lamination. This is when the joining area is not region is not any is selective. Okay, and this coating is adhesive. Paper sheets, and here joining is through laser CO2, and the what already I have mentioned, and this is the bond then form. Okay, we have main point here is we do not have bleaching. We do not bleach. Okay, and selective deposition laminate is also known as SDL, and this cutting area, this is known as decubing stage, where I already said load is applied, and this is the single hole. So this is about the cubic technology NOM, and one more thing is there, that um, so the questions, major three questions which arise from this process is like what type of approach you are using, and second question is support material. How do we remove the support material? And uh, support material is removed in the decubing stage, where we can see this our final product. This is the decubing stage, and why this is called as third question is raw material is nothing but paper. So this is the major three questions which is important for this method. Uh, okay, so this is a pretty and why this is called as um, SDM, SDM, selective deposition laminating in some cases. So this is the only theoretical question type of. There are no such numericals related in this technology in your assignment, related to assignment. So with this, the main thing is the power required is very less. It's very less as we are using adhesive for bonding. Okay. So now the next method. The next method is Kira's paper lamination technology. Now, uh, this is the P. So Kira's paper lamination technology. Here also the material is paper, approach is similar like bond then form, but here the cutting knife method is different from the previous method. Cubic technology. Here the cutting method is knife. Bonding method is again similar to the previous technology. Adhesive and joining region is entire. Okay. So now in this process, we generally don't make it horizontal. Suppose, I'll just draw. something I'd like to mention here. This is through the Kira Corporation of Japan. Okay. So suppose I want to print this object, and this is not horizontal. I want to tilt it by 10 to 15 degrees. Okay. So one of the reason is that suppose if you're making a part in such a way, you have to remove this portion, and there is extra portion that is support. So that will be present during the joining process. Then this support layer will also be joined with your final product. So it will be very difficult to remove. So if you make it a little bit tilted, what will happen? That decubing will be very easy. So it will be easy to decube. Easy to decube if you tilt it little. If you tilt by 10 to 15 degrees. So this is the reason. So this is one of the reason why we tilt a product little bit. And another reason is that when you are using a roller to join the two adjacent surfaces, suppose this are two adjacent surfaces when you are using a roller. So what will happen is layer is one layer is like this. Okay, this is one layer. Suppose this is one. Okay, I just deleted it by mistake. I'll just. Okay. This is one layer, and this is another layer. Both are equal. Now we are tilting it by 10 to 15 degrees. The reason we are tilting is so that decubing is easy, and there is a shear force between okay, so within these two layers there will be a shear force. Okay, now our aim will be to decrease the shear force by tilting. Decrease the shear force. Reason for tilting is decrease the shear force between the two layers. Now, what will happen by decreasing the shear force and tilting? There is slippage of both the layers. So, when shear force is there, when shear force between two adjacent layers, so one layer will try to slip, and if some slippage is there, we have accuracy of the accuracy of the final product will be different, and strength will also be different. Okay, slippage is there, then accuracy and strength of final product will be different. So we decrease the shear force between two layers by tilting it a little. Tilt a bit. Okay, so we tilt a bit and decrease to make the tubing easy and decrease the shear force between the two layers. So these are a very important point. Okay, why? What will happen if shear force is there? Slippage will be there and accuracy or strength of final product will be different. Okay, now I hope this is clear. So now this was developed by Kira Corporation, as I already said, is a Japanese company. And the difference which you see that in the instead of CO2 laser, we are using a knife or wire. Also, we can write wire in some cases. Okay, so this is this. So here you are seeing this. Image where you are seeing this cutting knife which is used, and now we'll discuss what is the advantage of using a knife. So when we use a laser is costlier as compared to knife. Okay, advantage of laser is comparatively costly as to a knife, comparatively costly. And here we use, okay, so now paper sheets. Now this here it also consists of paper sheets. The cutting approach is different, but the material and the approach, cutting method is different. The approach and material is same as compared to cubic technology. When we use a laser on the paper, if we put some fire on the wood, what will happen? It will create some fumes which are toxic. So this is an advantage of, again, an advantage of knife. What? So laser is, first of all, it is costlier. Also, knife is eco-friendly. It won't spoil your product. It won't spoil your product also. Just one more point. Put some fire on the wood. It will create fumes that are toxic. This is in case of laser. In case of laser. Okay. Now, in the last process in cubic technology, we were using a roller and it was moving across the layer. But in this, we do not use a roller. What we do is we just press the layers. The layers are pressed on one another, and so that there is no shear force between the layers during the pressing, and we can use a higher amount of force as compared to the first process. So what will happen is when we use a higher amount of force, because there is no shearing, so we find our quality and strength increase. But again, as I said, we tilt it a bit. Okay, to avoid slippage. So this is so when we use a higher amount of force, there is no shearing. So we find our quality and strength of the final product will be higher as compared to cubic technology. So this is another difference for bonding. When we are using adhesive, and our joining region. Um, so adjoining region is again entire. The joining region is here entire. Okay. So we discussed all these points. Now I would like to say that, okay, one layer is there, as you saw. Second layer is there. Now like this. So both layers, as I told you, the strength of this thing is higher as compared to the cubic technology. And one more thing, what we do is we use a roller in shearing action. So it may happen that we try to curl, okay, this will try to curl, and um, in some case final product is little bit tilted. So but in this case we are just using a heated plate, like you so here, to avoid this, so that there is no, we are using here a heater. You are seeing here the heater. Okay, so what we are using is just using heated plates, which so that there is no curling, and accuracy of final product is better as compared to the first process. And so these were the salient points for Kia's paper lamination technology. One is your cutting method is different. We have knife here, and the joining region is entire here, and we use some methods, the tilting, and we use the pressing mechanism rather than adhesive. Uh, the pressing is completely, and the strength and accuracy of the final product is much higher. So now we will go on to the next one. This is the solid dimensions plastic sheet lamination technology. Okay, so here one more, as you see, the material here is plastic. In the previous both methods, the material was paper. Cutting method is knife, and joining region is selective. So these are the difference in this current method. Now we'll understand what is the difference between the first process and in this process. The first thing is that, as I said, the material is plastic. In the first two processes we use paper. Now this plastic here, it is mostly thermoplastic sheet. Thermoplastic sheet. And these sheets are transparent sheets, and the approach is same. Bond then form. These are transparent sheets. First we are making a bond, and then we are giving a final shape. Uh, Final shape where cut, and the cutting method is also same, where we are using a knife, and bonding is again adhesive, and we'll put a bond adapter between the two adjacent plastic sheets. But here one more difference is that joining region is selective. In the first two processes, what we did is putting the adhesive on the whole sheet, but here we are not will not put a adhesive on the whole, so we do a selective so that final product is in the shape of the cross section. Suppose, so this is the, suppose okay, suppose this is the final product. So we put the adhesive on this selective adhesive. We put, and we extrapolate this area. Extrapolate. So supports requires peeling off for this. So this is why we have a separate trimming, peel off. Now this, because of this joining region is selective, So support removal is done through peel off. Now Now, okay. So the extra portions we extrapolate and we remove the supports in during the fabrication. So what we do is one of the layer and there is one more layer like this as I showed you. Only at one location we are joining the these two adjacent layers. So there is a support removal flow up and this is the flow chart for this entire process. So first what we do is we do masking, this is the joining region and the joining region is selective. Second is application of glue only in the portion which is required, final product portion, and then we do a ironing. Ironing is nothing but trying to apply a force and trying to join the two adjacent layers, and then cutting the extra portion, and trimming is nothing, just peel off. So this is again the bond then form kind of approach where the raw material is plastic. And one more question is how the joining region is there. It is in the form of selective and not the entire. So these are the most important questionnaires for the this particular product process. So we discussed material, approach, cutting method, bonding method, joining region. And the most important for this is the joining region is selective. And the material is plastic. Plastic is, we have some plastic sheets which are transparent, thin layer of transparent sheets. Okay. Now we move on to the next method. Okay, yeah, we'll resume. Okay, so the current next process is computer aided manufacturing of laminated engineering. So here the material is ceramic, approach is form then bond. Earlier it was bond then form. Cutting method here, earlier it was once it was laser, once it was knife, and previously it was also knife. So this is cutting method is laser. Previously bonding method was adhesive, now bonding method is sintering, and joining region here is entire. So we'll understand what it is. Computer aided manufacturing of laminated engineering. So this metal is mostly used for ceramic. We can also use this method for metal is also possible, but it was developed for ceramic because we already had process for papers and plastic. So people try to develop one process for ceramic. So in this approach, we can see that first one layer is in the form ceramic or metal. Now form then bond. This bond is centering. Okay. Now Now in this, we are first giving a shape to the layers, then bonding in the centering process. We are first giving shape to the layer and bonding during our centering process. So this process is opposite as compared to the other three processes, as here it is our form then bond. Shape to the layer and bonding during setting. That is why it is form then bond. This is a very important point. Earlier it was bond then form. Sorry. Now, uh, here the cutting is using a laser and bonding method. Previously we used adhesive, now we are using sintering. Now, during this entire phase of joining bonding method is usually the joining bonding method is diffusion. Bonding is diffusion method. Now, here the joining is again entire. Joining is again entire. So, what is the entire region? Actually, the layers are already in the form of final product. Okay. So, the layers are already in the form of final product. So, we don't have to untie or selectively do anything. But the final thing which we have is taken in this shape, and that is the form of final product. So, we have to, this is a very much this is the advantage of this process, that we do not need to make any uh, uh, we need do not we do not need to make any separate channels. Like we are, this is the final product, this is as it is, we are receiving it. So what kind of approaches? That is why this is known as form then bond. Now, the advantage here is there is no unwanted material in this. We do not need to remove any supports or anything. And here, this you see, this is the methodology. We have a CAD model, contour representation, slice cutting, is done through laser, and then stacking, formation of layer by layer, and then lamination, finished component, and conventional binder removal and sintering. Sintering, that is the bonding, takes the last step. Now, uh, now there is a problem. If suppose uh, since the sintering is, what we are doing is sintering should be enough. Okay, so one layer of there is possibility, or that one layer is one material and another is of different material. So it should be comparable, that we miss the temperature for sintering for some particular layer. Okay, so during that phase, what will happen is a lot of shrinkage will occur if you are using a very complex geometry and thickness of the wall is very thin. So if you are trying to paint the thin wall, because of this process, it will be very difficult because it will try to buckle at some point. So nowadays we are getting metal filament wires, which we can use in the various processes, so that we can give a shape to final product like this uh, thing. But by using a printer. Uh, but we have to center it. But the only problem is there in during the centering case, the dimensions will be changed. So we have to take a tolerance of like we have to take a tolerance of 1 or 1.2, so that if the complex geometry is too complex, so that there won't be shrinkage. And again, if the geometry is too complex, it is not possible to fabricate with this type of processes. But either the layer resolution, if we have somewhat with 100 to 600 micrometer or thicker layer is available, then this process will be comparable with other processes. But in other processes, like we had sheet of paper which is around 5200 micrometer, and if we compare with this process, we generally use somewhat 20 to 30 or 50 micrometer. So this also depends on the powder size as well as the type of material. Suppose we are using aluminium and we use 30 micrometer, and for titanium alloy we use 50 microns. Then this depends on the company, because some companies take 30 micron, because the variability will again depend on the company to, it will vary from company to company, because the powders that we are getting from the company is of similar size. Then we don't need to regulate the thickness of the layer. So this is the advantage and disadvantage of this process. I'll just write one more point for this. Here the layer resolution is 100 to micrometer. Previous other processes, it was 50 to 100 micrometers, and for epsilon, it varies from 20 to 30 or 50 micrometers. So this is the major difference for this process. First is that you have your form then bond approach, and the material is ceramic or metal can be done, and bonding method is simple. Now we'll move on to the next technology. This is the ultrasonic consolidation method. Now this is the last process. Now this is mostly used for metals, and this process is also called as hybrid process because in this we are using a subtractive as well as additive process. Hybrid process, subtractive or additive process. Now this was invented by Politica Incorporation in 1999. I think it was in USA. Now, okay, and this is a subtractive for hybrid process, subtractive as well as additive process. It's in subtractive, so it's in subtractive we are using a building process, additive we are joining different layers. We are building a whole component in the form of layer. That is why it's known as additive. Now, it's also known as in some case it works similar in to your ultrasonic welding process. That is why it is also known as ultrasonic configuration. Now this process was invented by Politica in 1999, and in 2011, because it is similar to the building process, so this process got this this process got this company already, plus adhesion welding they joined hands and they commercialized the product in the form of fibers. So mostly you will not find this in any institute, and this type of process has not entered. It is not just commercialized. It is not entered uh, India yet because it requires a milling process. So it is not that much efficient. But in this process, it is possible to build very big components. Okay, uh, and that is also possible with the processor. And here the accuracy is very much higher as compared to the previous process, as you have to do a lot of machining in the final product. But here, after the milling, your accuracy will be good, and again thickness of the metal sheet is 100 micrometer, and we can use stainless sheets also because we are just rubbing two adjacent sheets. So if the sheets are thin, it may happen that at some point it may break, so it will be very difficult. So that's why we are using little bit thicker sheets here. Okay, here the sheets are 100 micrometers. Cutting method, this is a very different method. Milling, bonding is diffusion, and thickness of metal sheet 100 to 150 micrometer. Now the bonding method, which is diffusion, is ultrasonic metal welding. Here temperature is 200 degrees Celsius. Solid state welding happens. Okay, and now we'll understand this entire setup. Okay. I just mentioned that this whole process takes at a temperature of around 200 degrees Celsius, and the solid state welding, there is no melting in the solid state. So approach in this is bond first and then form, and joining is selective. So and it depends on the final product. Okay, so here we have to remove the whole portion so that according to the building process. Now in this schematic diagram, we see that there are different components that are available in the ultrasonic consolidation process. We have a transducer. You might have seen this type of transducer booster. Um, I think in ultrasonic EDM machining, and this is the same type of almost same type of setup where the shape of there like various other micro machining processes. This will be happening. Now we have this. We have this ultrasonic split oscillation. Now, oscillation here is in the transverse direction, which you are seeing. It will vibrate the transverse direction. Now, what will happen is this, when this oscillates, now this will vibrate, and the frequency should be in the ultrasonic range. Now this is nothing but around 20 to 22 kilohertz based on various ultrasonic properties, and there are same level of frequency used, and the amplitude of oscillation is between 5 to 40 micrometers. Um, so, and that is in this transverse direction. So the transducer is nothing but a piezoelectric. When we apply a current in this, it will try to vibrate, but generally the amplitude that we get from this piezoelectric is not in this range. So to amplify the amplitude, we use a booster. So what level of amplitude can increase? It can increase. That depends on this design of the booster. Uh, so now you can see how in making a step manner, so that depends on the shape of and diameter of the booster and frequency, how it is. This is again the approach function of the user. Okay, so this was about the transducer and booster. Now, what is the function of transducer? It will convert the electric energy into pressure, and the sorry, and it will convert the electric energy into pressure. The Now here it is nothing but the mechanical energy, and the bonding mechanism is diffusion. So the ultrasonic welding is around vertical raw material. Raw material is our metal sheet, which are around of the thickness 100 to 150 micrometers. Now when we increase the amplitude of vibration, like I told, a booster which is used to amplify the vibration, and unwanted material, we remove the unwanted material, for which we use the milling, uh, for which we use the unwanted material where is removed by the milling process, which will cut out. So these are the basic things for this process. Uh, okay, there is also in this method, yeah, these are the salient important points for this method. I'll just write quickly. There's the transverse direction, the movement upwards. Frequency is around 20 to 20 kilohertz. Amplitude is 5 to 40, and thickness of metal sheet is 100 to 150, and the ultrasonic melting happens by solid state welding process. Okay, so these were the salient features for this topic. Now, the most of the assignment questions will be revolving around the points which I said. Um, so now we'll discuss quickly some of the questions. So now let's start with the question. Okay. Which of the following is the correct match? This is a very straightforward question. Which is the following is the correct match for sequence of operation for cubic technology LOM? So, like we saw in our okay. So, like we saw in our question, the correct option is first option. This is regarding the cubic technology LOM. Is the sequence which about which we are talking about. We already discussed this in detail. So the sequence of operation is paper, bond, then form, laser, adhesive, entire. Now, material, this type of material which we use is paper, and of course is bond then form. For this, the correct option is material is paper, approach is bond then form, cutting method is laser, bonding method is adhesive, and joining region is entire. The other options are not for this uh, cubic method. This is cubic technology alone. Now, the next question. In cubic technology alone, decubing is a part of which phase? Okay, so this we know. The decubing is a part of the post-processing phase, and we also discussed what decubing. It involves the removal of the excess or the unneeded material from 3D objects, such as support structures or any excess material that may have accumulated during the building phase. It's an important step to ensure that the final object is clean and ready for its intended use. So post-processing occurs after the 3D object has been built. Okay. Now pre-processing and building object already we have discussed previously. Next is which of the following technology use CO2 laser in cutting method? Okay. So quickly we saw that CO2 laser is used in cubic technology LOM, and knife is used in PR paper lamination technology, and also in PM method we use laser. So according to the options, the correct option is cubic technology LOM and CAM lab. This uses knife and ultrasonic consolidation also. Ultrasonic consolidation uses the cutting method as milling. It uses milling. Now next question is ultrasonic, we already discussed. This is a hybrid type of method. This is a hybrid type of method where the process is both subtractive and additive. Both subtractive and additive. So this methodology, it is an in situ material removal process. Material removal process through a 3-axis CNC contour milling. And the major advantage, as we already discussed, it is a very energy efficient process. Now the next question. Okay. Which process parameters is correct for ultrasonic consolidation? Higher vibration amplitude, greater ultrasonic energy delivered. This is the correct option. Now, some other process parameters are travel speed, temperature of base plate, stiffness of the machine, stiffness of the substrate, hardness, presence of subsurface contaminants, and oxides. Now, we saw in the ultrasonic consolidation method, and we discussed about the vibration amplitude, how and how the entire schematic we discussed, how we use the transducer booster to control to increase amplitude, and how the oscillation occurs in transverse speed, and how further it gets converted to displacement. Now, the vibration amplitude, it was approximately around 5 to 40, and higher is the amplitude, higher is the energy density. Now, the next question. Which method uses plastic as raw material? This is very easy question. The method is solid dimension plastic sheet lamination, where the material was plastic, which we saw. Approach is bond and form. Cutting method was knife. Bonding method was additive. And joining region was selective. Now, this is plastic. This has raw material as paper. This has paper, and this also has paper as raw material. Only exception here in this case is the solid dimension plastic sheet lamination uses plastic thermoplastic as raw material, and the sheets are transparent in nature. Okay, so the next question. How are Kira's paper lamination technology and cubic alloy different? Now, we discuss here. Here the cutting method is Kira's paper lamination technology cutting method is knife, and this is CO2 laser. This is the major difference. And the parts here are accurate, are smaller and accurate than LOM, cubic LOM. Cubic LOM. So this we clearly discussed here, and the advantages of Kira's paper lamination technology also we discussed. How the laser is comparatively costly, nice for the Kira's paper lamination is eco-friendly, and we won't spoil the product. Strength and accuracy of the final product of this method is also much higher than cubic alloy. Now the next question. The correct option here is cutting. What are the advantages of NX Corporation offset fabrics? Now, Minimum shrinkage and wide variety of these two are advantages of this method. No unwanted movement in internal channels are possible are advantages of CAM. So here in this CAM method, we saw this is the final one product where these internal channels are possible in this method. Since it is a form then bond approach. Since first the model will be sized and will be formed, then finally the sintering will be happening in this method. So these were the questions from my side. Any doubts? Yeah. So any doubts? This was a very basic uh, lecture about the methods only, where you have to remember what is the material approach cutting method, what is the difference between the previous method, and what is the advantage of one method over another, what is the disadvantage of one method over another. You have to identify which material can be related to which method and which method can be used in some particular cases. So you have to just understand and remember. So the questions are also pretty clear and straightforward for these type of theoretical methodical approach. If, are there any questions we can discuss? Okay, so if there are no further questions, we'll end the session. Thank you all for attending the session. Let's meet again next week. Thank you. Yeah. Any doubts? Your voice is not audible. You can type in the chat box if you want. Hello, Karthi. Do you have any doubts? Your voice is not audible. Can you write in the chat box? Else you can mute yourself. Okay, so if there are no further doubts, we'll end the session. Thank you all for attending. Thank you. Okay, you have a doubt from assignment 5. Okay, which question? Yeah, your voice is still not clear. You can write. Meanwhile, I'm opening the assignment. Hello. Yes, Karthi, your voice is not audible, so you can write in the chat box which question you have a doubt. I'll discuss that question. There is a disturbance from your side. That is why I'm asking you to write it down in your chat box.
Madam, now audible?
Yeah, yeah, it's all.
Madam, actually, assignment number 5, I
Yeah.
didn't submit, madam. Actually, I tried at
Okay.
night time only. That is 13th August night time. At 10 o'clock I started, but I can't complete within that 12 o'clock. 11:59. It is actually I click all the answer,
Mm-hmm.
but during going to be summation that it shows that the time is end like this.
But
But anyway,
it was not the 12, 11:59, right?
11:59 it is closed, madam.
Yeah,
Correctly.
but you submitted before that. You tried to submit before that, right?
Before that, but here I am staying here, Odisha, madam.
Okay.
Due to that, some rain, continuous
Ha ha
rain,
ha
power
ha
cut is
ha.
there,
Yeah, yeah, yeah.
so I can't submit.
Mm-hmm.
So, but anyway, I have doubt in, but I can't submit because
Mm-hmm.
my total assignment is zero only.
Okay.
But anyway, my answer I am telling, madam.
Okay.
Uh, question number.
Yeah. Yes.
Question
Please.
number 6, madam. Actually, my answer is
Mm-hmm.
question number 6 is B. But here, as per the answer, the question number answer is subdivision. Answer is option A.
Okay. You are getting TI is equal to TII by 4, right?
4. But that my answer is that Ti is equal to 4 times of T double I. But here option is Ti is equal to Ti divided by 4. So the okay, by mistake they given, I think that's only I choose that one. But as per the answer, first is the subdivision A is the answer. Correct answer is there.
Okay, just a minute.
I got the answer Ti is equal to 4 times of T
So,
double I.
how you solved it? Just tell it briefly, just like how you did it. Uh,
Wait a minute. Actually, wait, madam. I am taking that
okay, yeah, yeah,
solution.
yeah, yeah, sure.
Actually, deep dipping.
Deep dipping, huh?
ED is equal to directly proportional to the 1 divided by HD square.
Mm-hmm.
So by that, that means lowest value divided by highest value is equal to highest value divided by lowest value square. So by this, I got that 4 times of T double I.
Okay, so this seems even I did not solve this. So I'll surely look into it and see what is the final answer coming. But as per your saying, it should even it should come for TII. So I'll
Wait,
just
madam, madam, I got
okay.
that. I solved like this. TDI
Uh,
directly proportional to 1 divided by B square.
D square.
And
Okay.
one more thing, TDI directly proportional to 1 divided by 2B square. So
Okay.
1B square is directly proportional 4 times of B square. So
Hmm.
4 B square cancel.
Hmm.
So TDI is equal to 4 times of TDI.
Yeah.
TD
So
double I.
I'll just take it up, mention this. Uh, since you did not solve it, I'll suggest you just ask this question in the announcement tab so that
Mhm.
suppose this answer is wrong, it will be corrected. Okay.
Okay, madam.
Yeah, I'll also put this uh, in the like the other TAs for correcting this. Okay.
Madam,
So
and
then,
one more thing,
yeah,
question number
yeah,
8.
8.
Actually, I
Huh.
got the answer D. D, but here answer is
Eight.
subdivision B is the answer. I
Eight.
got the because time and HD both are if HD increasing, HD increasing, time will be reduced. But this whether I am which one both are giving the but here this linear first gradual first suddenly decreasing then increasing HD. Option number B. I am telling the question number 8, madam.
Yeah, you got the answer option B.
I got the question number 8, option D.
D you got, okay. Or you are saying it is linear.
Linearly, gradually reducing. HD increasing, time is reducing. But here
No,
answer is accepted
this
answer is
this
subdivision B.
yeah, this is correct as per the answer given. Actually, we can refer this in the slide also. It is written, just like give me a moment. Decoating time and deep data.
Actually, sir told madam, if HD is increasing, time will be reduced. So that's only I chosen this option number 4.
Yeah, but it need not be linear. That is my point.
Uh-huh.
So here that is one second. Let me just open the slide that will clear. Do you remember which slide by chance? Second one, I think. Week 5, second
Which is
slide.
actually I saw YouTube channel, YouTube only, madam.
Okay,
Slide.
okay, okay, okay. Hmm. No, here the option is correct. It won't be linear. So since
Hmm.
it won't be linear, the only option left is uh, D. So
Wait a
let
minute, madam. I am taken notes, so I will check it that one. Which topic?
no, yeah, that won't be linear. The deep dipping height and um, the time, recoating time, that won't be linear. There's a formula for that. So related to with that formula, you will get this relation. So I'm just switching
Madam,
paper.
the recoating 6 steps, sir told them leveling,
Yes,
deep gripping,
leveling, deep
elevating,
dipping, elevating, sweeping,
dipping.
obtaining wheel position, and
After
Z.
that, the deep dipping. That
Z.
that section, madam.
Yeah. See, in option D, you have that your
My answer is I chosen this answer, but anyway I not actually for me times up, madam. That's only for
okay.
me 0 mark only. I tick this option number D during that
Yeah.
day.
Okay. So one next, I'll suggest you next time, please submit it before, so that
Okay, madam.
you won't face this problem. Uh,
But this assignment very easy, madam. But I can't attend, can't submit it.
the coming one you are saying?
What, madam?
The coming assignment are you talking about? The easy?
No, no, this assignment, fifth assignment, madam.
Okay, okay, yeah. Yeah, if you go through the videos, you will be very much clear. So what as my answer is, since this is not linear, so
Hmm.
your option D will be considered the correct. So here I'm not exactly remembering the formula now. One second. The other question I'll surely discuss and uh, uh, let you know, because even your approach is correct. That will be 4 times.
Hmm. Madam, 12th question, madam. Similarly.
12. One second. Hmm. Ratio TA by TB, right?
Two objects they given, madam.
Yes.
Actually, madam, he told that one sample printing time, which is if n number of samples printing time both are same. Uh, Madam, audible?
Yeah, yeah, yeah. Yeah, please go ahead.
But that one, question number 13, okay. According to question number 13, okay, one is correct.
Mm-hmm.
Both things are ratio is 1. But question number 12, question number 12 is the according to deep dipping.
Hmm.
So I got the answer 25,
Hmm.
because they actually 25 how I got. So a cross section area, sir told me cross section area, surface area cross section.
Mm-hmm. Here the surface area is same for both, right? That is why it is one.
Surface area both, but I done that 100 into 100 just to multiply this. How much is sample? I think 1, 5, 5, 10, 15, 20, 20 into multiply like this. I taken